Welcome back to Algebra 1. This is the last thing we're doing. We're continuing to solve rational equations, but the last thing that we have is because we simplify the problem to get our solution, there's a possibility that we get an answer that doesn't work. That's called an extraneous solution. So although we're not going to get quadratic equations that we then have to do all of those steps of quadratic solving, that can happen. That'll happen when we get into Algebra 2. But we can, because we simplify the problem, get something that looks like a solution. But if we tried it in the original problem, we would have division by 0. And we can't do that. So the number that we get actually doesn't work in the original problem. The second thing that we need to look at is our least common denominators are going to get more complicated today. And they're going to possibly have addition and subtraction inside of a factor. So the least common denominator is the factors of the denominator. It can end up having a couple terms if we multiplied it out, but we would rather deal with, I know that the factors of 4x plus 36 are 4 times x plus 9. And parts of these can be under different parts of our problem. So the addition and subtraction is okay, but we're usually going to have it inside of parentheses. What we don't want to do is decide that, well, 4 is a factor, 9 is a factor, and x is a factor, so we don't want to end up with a factor that says, oh, the factors are 36x, with nothing else inside that. So our factors are going to get a little bit more complicated today. Now we're going to start out with something that has a specific term in it. We have x plus 5. Okay, so since that is the denominator, it has to be the whole possible least common denominator, x plus 5. So I'm going to put that with parentheses. What do I look for the next one? Okay, I have the same thing, x plus 5. And in my last one, I don't have a denominator, so that means my least common denominator is x plus 5. So I'm going to multiply the entire problem by x plus 5. And x plus 5 divided by x plus 5, first term is 6. X plus 5 divided by x plus 5, 1, minus 1 times x plus 5. So when we simplify this, so we have 1 minus 5 gives me negative 4, with a negative still in front of the x. And we're going to add 4 to both sides. And then our last step is divide by negative 1. And x equals negative 10. When we have this least common denominator that we're looking for, sometimes the parts will get multiplied together. So we have this guy here, b minus 1, so that's going to be part of it. And in order to keep that as a factor, I've got to keep parentheses around it. This 2 here, that's a new one, so I have to multiply times 2. Now this guy is actually those two things multiplied together. So if I factored this guy, I would get 2, and then parentheses b minus 1. So I can see that my two separate things that were over here are in this guy. And I found that by factoring it. Now in this particular one, I like to keep them as separated factors. So I'm going to multiply everything by 2 b plus 1, b minus 1. So that times my Now I wrote this out long because I want to make sure that we cancel the things that we can cancel in each of the separate terms. So I wrote the least common denominator times each separate term in my problem. In this case, this is going to cancel. In the second term, the 2 will cancel. And in this third term, this multiplied out gives me this, so the entire thing cancels. What we are left with when we multiply that out is this. So now we're ready to simplify by distribution. I look forward to not writing with a mouse anymore. And 1 distributed to this gives me b minus 1 minus 3. Okay, that is now a simpler problem for us to solve. So now, when we simplify this, we're going to get b minus 4 here. And since this b is the smaller b, I'm going to subtract b from both sides. That's going to give me b minus 12 equals negative 4. And I need to add 12 to both sides. And b is 8. Okay, in our next problem, now the simplest thing that we have here is where we might start, is this guy right here. I know that my least common denominator is going to have to include b plus 6, and I'm going to put parentheses around that. And what I notice about my other two things here is that b squared plus 6b can be factored. I get the greatest common factor out of this. That means I'm going to divide both of these by b. And when I do that, I put the b on the outside, and I end up with b times b plus 6. So what I notice is b plus 6 is part of my least common denominator, but it includes the b on the outside. Okay, so in this particular case, I am going to write out that I have this least common denominator multiplied by each of my terms, and then what I want to look at is for each of my terms what cancels. This is the entire thing here, so I'm left with 1. This is the entire thing here, I'm left with 3, minus. This is the only part, so I end up with 3b. So I'm going to subtract 3 from both sides, giving me negative 2. And divide both sides by negative 3. And b is 2/3. Now, sometimes you're going to have to factor in order to be able to recognize what your different terms are. So in this particular case, I need to factor this guy and recognize that he is k plus 1, k minus 2. Now the reason I have to factor that is, look, k minus 2 is already in here, so this whole guy is my least common denominator, but I wouldn't necessarily recognize that that was the only thing I needed unless I actually factored it. So we factor this part. Now, we're going to multiply all of our terms by that. So when we multiply that by 1 over this, now usually when we write out the least common denominator, we write the factored form of it. But we recognize that when we multiply these two things together, we get this k squared minus k minus 2. Okay, there we go. Okay, so this cancels completely here. We're left with 1 minus, this is the only part that's going to cancel here, so this one becomes, and I'm going to put the whole number in front of the parentheses. Remember, we can write those both ways, but the parentheses have to be around k plus 1. And on my last term here, the entire thing cancels, so I'm left with 2. So simplifying this, we get negative 6k minus 6. Okay, we combined like terms, so now we can add 5 to both sides. And divide by negative 6. So k ends up equaling, remember we don't put the negative in the denominator, so negative in the top or in front, negative 7/6. So that's our final answer. So an extraneous solution is a solution, but it doesn't actually work. It doesn't work in the original problem. And one of the first ways that this doesn't work is because we're going to plug it into the original problem, and when we try to start solving that, we end up with a 0 in the denominator. We can't have that, so that's not a solution. So our first step to solving is we need to find that the least common denominator is actually this 4x squared plus 6x. So we're going to multiply our entire problem by 4x plus 6 and x. So we factored this guy. Well, we want to factor this so that we can see in this first term, least common denominator divided by x. Well, what we have left is 4x plus 6 equals this divided by this cancels, we're left with 1. This divided by this cancels, we're left with x minus 1. 4x plus 6 equals x. So we are going to subtract 4x from both sides. And divide both sides by negative 3. And we end up getting that x equals negative 2. So it's kind of nice right now. We got it to be a whole number answer. So now what we need to do is we need to test for extraneous solutions. Well, the first way to test is to go back to the original equation. So I'm going to plug this in for every single x. So I need some room here. So we're going to have 1 over negative 2 equals 1 over 4 times negative 2 squared plus 6 times negative 2 Marilyn. Okay, so there it's substituted in, and we want to clean this up a little bit. Four times negative 2 squared, we have to do the negative 2 squared first. So 4 times 4 is going to be 16 plus 6 times negative 2, that's going to be negative 12. So this denominator ends up becoming 4. So this is 1/4. And then here we have negative 3 over 4. So if we simplify this side of the problem, we're going to get 1/4. This is going to be minus plus a negative 3/4. And that is in fact negative 2 over 4, which is 1 over 2. So this does check out, and it is a solution. Okay, that's the first test. It's kind of the harder way to go. The second way that we can actually test these is because the thing that causes a problem is the denominator can't equal 0. So what we do is we just find the least common denominator. We say, hey, it can't equal 0. So we set each factor of the least common denominator equal to 0. Solve that with this not equal to instead of equal to. And if one of our solutions turned out to be that problem, we would say, oh, sorry, that's extraneous. So here's our next problem. And we obviously need to factor this guy. So when we factor this, we're looking for the factors of positive 10 that add to give us negative 7. And that will be negative 5 and negative 2. Now that's going to work for both of these. They are identical. And what that's going to do is this is what I am multiplying every term by. So my entire problem gets multiplied by x minus 5 in parentheses and x minus 2 in parentheses. That means this is going to cancel and I'm going to be left with first problem is x minus 2. 1 times x minus 2. Plus, this is this entire thing factored, so it cancels. And we have a much simpler problem to solve. So when we simplify this, we're going to get x plus 3 and subtracting 3, we get x equals negative 2. Now how do we test for extraneous? Well, we set each of the factors. Oh, Lord, I can't write anymore. Not equal to 0. So each of our separate factors not equal to 0. So remember, when we move the 5 to the other side, this becomes positive. So x cannot equal positive 5, and x cannot equal positive 2. So the solution was negative 2. That is not included in these things that x cannot equal, so this checks out as a solution. Much easier to test for extraneous solutions this way. We're looking for the factors, and this is going to end up being n times n minus 4, and that is multiplied by every single term. So when I multiply this times the first term, everything in the denominator cancels, and I'm left with the numerator. Minus 1. What cancels is the n. I am left with multiplying this numerator by n minus 4. And in my last term, back to the original least common denominator, everything cancels. 6x plus 18. So now we simplify this. We're going to have 4n, because that's 5n minus 1n, plus 20 minus a negative 4 is 24. Remember, that turns to positive. So now we're going to move the 4x to the other side, 4n. And I'm also going to move the 18 to the other side, leaving me 6 and 2n. So n is 3. What can it not equal? Well, these two things cannot equal 0. So we're going to have n not equal to 0. Well, that wasn't one of my solutions. And n minus 4 cannot equal 0. So n cannot equal 4, which is not what we found, so we are good. Okay, your assignment is in Google Classroom, and have a good day.